Hi dear YouTube viewers, welcome to my video. In this video, we'll talk about polarography. Before we start, we have to understand polarography is quite tough subject to understand. But if you know about electrochemical, we can easily understand it. Before we start our today's subject, let's find out our purposes. Okay, electro plus chemistry. We have divided into 4 groups. Probably I'll make 4 different videos for every subject. Today's is polarography, colorimetry, kinetometry, and the last one is polarimetry. Polarography, polar. Before start with that, let's find out what does it mean. Polarographic method measures the amount of current flowing through an electrical cell. You might wonder, what does mean electrical cell means? Let me draw your attention to the fact that electrical cell means this kind of, maybe can we pronounce it as a beaker? Let's call him beaker. You know, beaker from analytical lab. So electrical cell means this type of glass, which like beaker. Should I have to repeat it again. Polarographic method measures the amount of current flowing through an electrical cell. Current flowing through amount of. Let's repeat again. Polarographic method measures the amount of current flowing through an electrical cell. And also I have to mention that this method is very, very sensitive. You have to be very, very careful when you start working with this method. So, if you know the definition of this method, let's move to the next part, which is we will talk about polarographic graph. Absolutely, polarographic graph. So we all know that we have to how can I choose it? Oh my god, what's wrong? It deletes all them. What's wrong? Sorry guys, it's my first time when I use this. What's wrong? So we have to draw this graph. What is wrong? Give me 1 minute, please. Here it is. Let's draw line. This graph is called a graph of current versus potential in a polarographic experience is called polygram. What does it mean? Polygram means when we have this kind of one result, let's draw it. Here, current. Here we have to value. Here we can apply it. Potential. So let's draw some result here. Okay, it's our result. So we draw the graph, which is called polyrogram. Okay, guys, and right now you have to be more enthusiastic. Let's imagine that you are in a lab work and you did everything very well. I mean, the steps that you add something hydroxide, upset chloride, upset nitrogen, and the computer or laptop gave you this result. How can I write your conclusion? How can you finish your graph? And of course, you have to explain it to teacher your answer. So let's learn it. Before, when we took this polygram, we have to divide this this line. Let's see this line into 3 groups, which is called from here, here, here. Okay. This is called residual current. Residual current. From above, it is called limiting current. Limiting current. You might wonder, you have already said that we have to divide into 3 groups, but here we can see only 2. Where is the third one? Do not worry, guys. We will talk about it right now. From this and to this line, we call it as a diffusion current. Diffusion current is pretty good. is diffusion current is dependent on concentration of ion light, but half-wave potential doesn't depend on concentration of ion light. So guys, you might wonder, what does it mean um, half-wave potential? Okay, let me explain. We already said that we can call this line as a residual current. This one is limiting current, and this one as a diffusion current. So we have to divide this line into two groups. In my case, it's this one. Okay, we divided, and we have to go down. As you can see here, my result looks like this, but it doesn't mean you'll get the same result. It's just example. You have to draw it more carefully. So, as you might guess, half-wave potential means not the full of the result. Half-wave potential means the half of the diffusion current. Can you see, guys? This is what? Full diffusion current. And this one, half diffusion current, half half wave current. Because of we only took half of them. So as I said before, the diffusion current is dependent on concentration of substances of unlike, but half wave potential does not depend on the concentration of unlike. So it was pretty good, guys. Yes. But I have to say that no, not always we get this kind of beautiful results. The next topic would be related to this graph, but it's a little bit. Let's draw it first of all. As I said before, here we can see current, you can see volume. Let's see the result. Okay, start from here. Okay. Oh, right now you have to be more enthusiastic, of course. Even more enthusiastic. Okay, you have already finished your lab work, and the computer give you this kind of result. You are terrified when you look at this graph at the first sight. Why? Because here we can see unusual line. Can you see, guys? Very, very, very unusual. Because it was in the very top, and after that, after going top, he also went down. Okay, this kind of result we call as a polarographic. Polarographic maximum. Do you know, guys, what's wrong with it? It means that your answer is not correct in here. You might wonder why we can get this kind of result. What's wrong? What's the reason of this? This case, the reason is because of because of streaming Hg drops. So I think you can get answers this your questions because we get this kind of results because of streaming Hg drops. But do not worry, guys. We can prevent it. We can prevent it by adding uh, by adding uh, reagents. We have some reagents that helps us to avoid it. First one is methyl red. It's not visible. Let me choose some nice one. Green. Methyl silicose. And the last one is Triton. X100. We have to add these reagents to our substance to avoid streaming Hg drops. So in this case, in this situation, we'll get a very beautiful and a very accurate answer. So let's talk about applications of polygraphic, and after that, let's find out the advantages of this method. The technique effective in the qualitative identification of unknown. Did you get, guys? This technique, polygraphy, is effective in the qualitative identification of unknown. Qualitative, what does it mean, guys? Qualitative means substance means we can have this kind of substances. Qualitative means qualitative helps us find out what's in the substances. It can be metal group or ionic group and whatever. Qualitative answers the question, what consists of this substance? And the technique also effective in the determination of very dilute solutions. Oh my God, it's a very, very good because we all know we often use dilute solutions. So let me repeat again. The technique also effective in the determination of very dilute solutions, and also can be used to study the rates of chemical reactions that compete with electrode reactions. So last one, this technique also can be used to study the rates of chemical reactions that compete with the electrode reactions. So guys, I have finished explaining you. I hopefully it was very useful for you. So in this, in conclusion, I want to say that polarographic method is a very good method. I know one very big advantage is it can detect analyte in a low concentration in a dilute solutions. It gives us a lot of future opportunity and advantages to working on that. So polarographic is one of the best methods in which we can detect analyte in a low concentration or in a dilute solutions. So thank you guys. Thank you for watching. I really appreciate it. And hopefully see you guys in the next video.